some trash. Only got 7 bags in my trash can.
For our next objective, we are going to model the different operations of polynomials using concrete objects, and we are going to relate pictorial manipulations that model polynomial operations. So let's say we have these following representations. We would like to find the correct model of the product x plus 1, x minus 2. So the first thing that we are going to do is to write x plus 1 on this side and then x minus 2 on top, x minus 1 minus 1. Now it doesn't really matter where you write x plus 1. You can write x plus 1 here and you can write x minus 1 here. Remember that the product obeys the property of commutative property. So now we are ready to multiply. Similar to the box method that we used before, we can now distribute x to our x minus 1 and minus 1. So x times x is equal to x squared, positive. So we are going to get this representation of x squared. I want to emphasize that the product will always form a rectangle. So when you multiply a polynomial and a polynomial, or either a monomial and a polynomial using a model, the result will always be a rectangle. Next, x times negative 1 will give us a negative x. So note that I have here two negative x. If you are going to use this model or this representation, you will create a space here. And we don't want that to happen. So instead of using this, I am going to use this representation of negative x. So x times negative 1 is again negative x. Alright, next, 1 times x is equal to x. Instead of using this, now let's say we are going to use this. It will create a gap here, which again we don't want to happen. So assuming that we are going to use this representation of x. So next is 1 times negative 1, which is a negative 1. 1 times negative 1 is also a negative 1. So to better model, instead of using this representation of x, 1 times x, which is positive x, I'm going to use this representation. Then 1 times negative 1 is negative 1. 1 times negative 1 is negative 1. And this will be the model of the product x plus 1 and x minus 2. Note that the result represents a rectangle. Alright, let's have another example. So I have here x plus 2 and x minus 3. Now we can write x plus 1 on this side, or we can also write x plus 1 on top. Now let's say we are going to write x plus 2 here on top. So we will have x plus 1 plus 1. X minus 3, I'll write it here on the side, x minus 1 minus 1 minus 1. So let's use our distributive property. X times x is equal to x squared, positive. X times 1 is positive x. Again, instead of using this, I'm going to use this representation of x. X times 1 is positive x. Next, negative 1 times x is negative x, and I'm going to use this representation. Negative 1 times positive 1 is negative 1. Negative 1 times positive 1 is another negative 1. Negative 1 times x is x. Sorry, negative 1 times x is negative x. Negative 1 times 1 is negative 1. Negative 1 times 1 is negative 1. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Negative 1 times 1 is negative 1. So this will be the correct model of this product. And again, the result is another rectangle.
My lady, come, my lady, you're my butterfly, sugar, baby.
Okay, let's say we have this key. Let's find the model of this product. Now we don't have the expression, but this model represents negative x. So we can write negative x here. This one is represented by positive 1. This is represented by negative x. And this one is negative x also. So now we can multiply negative x by negative x, which is positive x squared. And positive x squared is represented by this. Negative x times negative x is also positive x squared. Now this one is positive 1. Positive 1 times negative x is equal to negative x. And negative x is represented by this. But I'm going to use this one to create a rectangle as our final product. Next, 1 times negative x is again negative x. Alright, let's have another one. So note that this is x, so let me just write x here. This one is negative x. Again, let's write this. The representation for this model, this one is a negative x, this one is a positive 1, this is positive x, this one is negative x, and this is negative 1. So negative x times x is equal to negative x squared. Negative x times negative x is positive x squared. Negative x times negative 1 is positive x. 1 times x is equal to positive x. So I'm going to use this model. And then positive 1 times negative x is again negative x, or is equal to negative x. 1 times negative 1 is equal to negative 1. So this will be the model of the product.
I'm chucking, you're looking for some rubbish. This is grouchy awesome.
Alright, now let's say we have and we would like to represent this product x plus 3 times x plus 2. Let's choose which among these options will give us the correct answer. Now there's so many ways on how to solve this. Now let's try to use our options to guide us to get the correct answer. Now if we are going to multiply x plus 3 and x plus 2, we will have, so I can distribute this, I'll get x times x plus 2. Next, distribute our 3 to x plus 2. So x times x is x squared. X times 2 is positive 2x. 3 times x is 3x. 3 times 2 is positive 6. I have here x squared. I have here like terms. So 2x plus 3x will give us 5x and then plus 6. Alright, so this is the product of x plus 3 and x plus 2. Now, if we look at our options, so this one is x squared. Now this one is x, so I have 1, 2, 3, 4, 5x. So I have x squared plus 5x, but this one is plus 2. Here we need plus 6, so A is wrong. Now let's check this. Option C, x squared. So this one is x squared. I have here 1, 2, 3 x's, and I have here plus 2. So C is also wrong. Now what about option B? This one is x squared. I have 1, 2, 3, 4, 5 x's. So x squared plus 5 x's, and then 1, 2, 3, 4, 5, 6. Alright, so this matches the product. So B will be our final answer.
You okay? Oh, yes, I'm fine, thank you.